Matej,
You have to set up the microphones also. Cool. Hello, everyone. Thanks for coming to our talk. Today, we're going to be talking about MaaS for the masses. So building your own monitoring as a service, why you would do it, how you would go about doing it.
So hey everyone, my name is Matej. I'm working as a software engineer at Red Hat at the OpenShift monitoring team. I'm also Thanos maintainer, Observability maintainer. That's about it.
Cool. My name's Moad. That's my face. That's my face. I work at Red Hat with Matej as well, and I focus primarily on what's called the Red Hat Observability service, which is how we gather a lot of telemetry for OpenShift from tens of thousands of clusters that are running.
We also wanted to give a shout out to our colleague Saswata, who was supposed to be with us. He was supposed to talk with me. He was also helping us with the presentation and giving us feedback. So if you're watching, Saswata, hi.
Yeah, he's alive. He just couldn't make it to Germany. Cool. So context. So what is monitoring as a service? It's pretty straightforward. It means you have a third-party service. You might own it, you might not, that you send metrics to. Why would you need that? Kind of the challenges around multi-tenancy if you're having multiple people use this. And then how to migrate to using MaaS. What are some projects in open source that you could use? What are some commercial products you can use? And how much will it cost you? I think that's an important question for a lot of people. Observability kind of exists in the space where everybody wants a lot of it, but nobody wants to pay for it. So that's always a sensitive topic when it comes to metrics. Before we start, though, I want to kind of get an impression of where everyone is in this kind of journey, if they are using monitoring as a service or not. How many people use Prometheus in production? Just a show of hands. So most people, that's good. At PromCon, most people use Prometheus. That's great. How many of those people use a third-party monitoring as a service? So a handful are smashing. That's much less than I expected. And how many of those people who put their hands up use a commercial one? So a third party. Okay, so about half of the people that put their hands up there. That's quite interesting. So before we go into why you might need monitoring as a service, let's just look at a typical use case. You have a Kubernetes cluster running somewhere. You have some pods in a namespace. This is a simplified diagram. And then you have a Prometheus that's scraping those pods. If you want to query those metrics, you access the Prometheus directly through the HTTP API, query range, everything else works fine. You can add it as a data source, and it's great. So there are some problems with that approach. You have a central point of failure for your metrics. If something happens to your Prometheus, you can't get your metrics, you can't run alerts, etc. So the kind of typical way that you would run it in a cluster is as a HA pair. As mentioned, there are issues with high availability, which is that both of them are scraping the same targets, as was mentioned yesterday. And then you just query one of them. And then if that one's down, you query the other one, or you set them both up with some kind of deduplication. So let's extend that use case. I've been building a service in a cluster. I'm monitoring it with Prometheus. Now I want to run it in different environments, maybe in different regions across the world. Now I have this problem of lots of clusters with lots of Promethei in them, and then me having to add data sources effectively for each one in Grafana, or having to go to the UI, the Prometheus UI for each one individually to query metrics for it. This isn't great. Whoops. This isn't great because it's quite laborious. If you imagine I have not 4 clusters, but 100 clusters or 10 clusters, this quickly becomes untenable. So really, a lot of monitoring as a service providers, projects, kind of invert the pull-based model. The talk before mine touched a little bit on remote write. It's awesome that you were working on it. But remote write's really cool. It lets you push metrics instead of pulling them. So you add some configuration to your Prometheus, you give it a target, maybe you give it a token if it's authenticated or not, and then you can just push your metrics there. And now you have all of your metrics persisted in one place. You can correlate these metrics quite easily. You can access them even if the source cluster is inaccessible. Maybe there's an AZ outage or something. But there are some problems with this approach, which is we're kind of making an assumption that everyone who's consuming this metric, or these metrics, sorry, are from the same group of people, group of users. So they're not isolated by consumer or producer. And now you've introduced this shared bit of monitoring infrastructure if you're running it yourself or if you're paying someone to run it for you, that has to handle all of these different potential tenants and how they interact with each other and where their data lives. So that's where this kind of tenant model comes in. This is the de facto way that a lot of these projects address this, especially within the Prometheus space. And that's where you identify your producers when they write metrics. So when they write metrics, they say, I belong to a particular tenant, and these metrics belong to that tenant. And then when your users come along, they'll use credentials for a particular tenant and access metrics just for that tenant. So that kind of solves the problem of multi-tenancy in inverted commas, where you have all of the metrics go to one place, but the tenants themselves are mutually exclusive, and they won't be sharing metrics. So Matej is going to talk a bit about the Prometheus data model.
So how can we enable this on the Prometheus data model level? Let's take a quick look. So as most of you are familiar, we're dealing primarily with time series. So where on one end we have metric name and a set of labels, right? And on the other end we have samples, which consist of timestamps and particular values. So how can we make this, how can we enable multi-tenancy based on this data model? It's rather quite simple. We can use labels to do this. So we can add a special label. For example, we can call this a tenant ID, which will specify the ID of the tenant that this data belongs to. And then it's just up to us to make sure that we inject this label upon ingestion of the data, and that we enforce this label when our tenants are querying the data. So in short, this is how we can do it on the data model level. So now, cool. Now we talk a little bit about what's MaaS, what's high availability setup, a little bit about the Prometheus data model. But there's more to this topic. And to kind of illustrate, we'll start by setting up our own imaginary monitoring service. And we imagine that we start with kind of a conventional setup. So we naively set up our solution, whether it's like a vanilla Prometheus, or we use one of the high availability offerings, Thanos, Cortex, Mimir. We put some labels on the tenant's data, and now we declare that we're open for business. And soon enough, more and more people will hear about our awesome service within our organization, and they will start to ask for access. So naturally, we let them all in. And finally, you will find yourself in a situation like this, where it's starting to look a bit too crowded. And we start to discover some facts about our tenants. We noticed, for example, this tenant in blue is a particularly big tenant, and they are sending us all the data they have, and they're hogging a large portion of the resources for themselves. Another tenant, the one in the yellow, got somehow confused. They misconfigured their Prometheus, and they are now sending a barrage of requests to our service all the time, effectively trying to DDoS us. In the green color, we have now a very important tenant, and this tenant represents our most profitable service. But now they're reporting to us they are unable to debug and monitor their applications because our service is simply refusing to serve their queries. So they are kind of blind to their deployments now. And in the red, we've seen that's not even our tenant or user. It's somehow a malicious actor that got into our internal network, and they are now spying on our infrastructure. They are reading our metrics without us knowing it. So we can declare that our service has officially collapsed. Whatever service level objectives we have set for ourselves, we cannot achieve them in this way. So as we demonstrated on this small hypothetical example, running a multi-tenanted monitoring service is not without a challenge. And the challenge is not only present in the dimensions you usually think about, like resource usage and scalability, but also in the organizational aspects. It prompts us to start dealing with questions such as who are our tenants, what are they doing, and how much data they are writing to us and reading from us. Letting everyone do what they want is obviously untenable, and we need some measures to make sure our tenants can play nicely and that we can attain the service goals we set for ourselves. As opposed to the traditional Prometheus setup where usually one entity is responsible for production and ingestion of the metrics, you as a service operator cannot presume any control over your clients. They must start sending you whatever and whenever, and you need to be prepared to deal with this. So implementing multi-tenancy measures is then what will serve as our line of defense. In a system dominated by the clients, we need to be able to create a back pressure, and this is what multi-tenancy opens the door to protecting our own infrastructure from becoming overloaded or compromised. Many of these challenges are not unique to the monitoring world, but they might pose a unique challenge in the context of providing a Prometheus-enabled monitoring service. So based on our hypothetical service, we'll discuss this issue one by one. And the following should provide you with like a framework about how to think about these problems and their solutions once you start seeing them in your own practice. So let's talk a bit about hard and soft tenancy models. This is one of the initial questions we might ask ourselves, meaning how we can organize tenants within our instances. And as opposed to the traditional single-tenanted solution, we'll want to host multiple tenants within a single instance to decrease the overhead in both operational costs and resources. There can be an exception to this, where our organization might have a legitimate reason to opting for so-called hard tenancy for some users, where there might be a particular need to have a tenant exist in a completely isolated instance, and this might be to minimize any chance of disruptions from other tenants, or there could be, for example, a legal requirement where we might have to isolate tenants' data completely as well. The concept of shuffle sharding is also worth mentioning here, and this is a technique that minimizes the impact of outages or noisy neighbors on an instance in a soft tenancy scenario by limiting each tenant to a shard consisting of a subset of instances. And this feature is, for example, available in the Cortex or Mimir projects, so you can go and look it up for yourself. Authentication. We obviously want to know who our users are and whether they are who they claim to be in order to stop any unknown actors. So just like when it comes to securing other web applications, there is a host of solutions available. You might opt for a simple password-protected endpoint with basic auth. You might leverage MTLS and authenticate your users based on certificate information. For more complex use cases, you might need to reach for a more complete authentication built on top of a user management system. And to do this, you'll need kind of an identity provider, meaning an extra service that can manage identities on your behalf. Maybe your company has their own identity provider based, for example, on Keycloak, or you could use one of the existing solutions that you might be familiar with and that we also seen today, like Google, GitHub, Microsoft. And a popular choice to do this is to use the OpenID Connect protocol, which integrates also with the mentioned third-party providers and builds on top of the OAuth 2.0 authorization protocol. Obviously, one caveat with doing this is that you're now introducing an extra dependency between your client and yourself, and meaning that if the authentication, if the identity provider is down, you might also not be able to serve your own clients. Authorization. Once we know who our users are, we also want to make sure they are only entitled to do what we want them to do. So naturally, our tenants should be only able to read their own data and write data on behalf of their tenant, with the exception of the cross-tenant view, which we might cover later. And for some tenants, we might also want to limit the actions they might do. So for some tenants, it might be enough to just write data or read data. And even within a single tenant, there might be different types of users, right? So for some users, we might not require read permissions, such as might be the case with the Prometheus clients, remote writing to our service, where the read permission is redundant, so we can kind of tighten up those privileges and we can remove the read privilege. Again, for simple use cases, this could be kind of statically defined in a configuration file, or for more complex permission handling, you can look at the Open Policy Agent project, which is a policy engine that lets you define and enforce policies. Finally, we know who our tenants are, and we make sure they can do only what we want them to do. We also want to limit the quantity of their actions. As we already mentioned, hard tenancy and shuffle sharding can give us kind of a baseline solution, but also a good way of ensuring that our tenants are playing nicely is to use rate limiting in order to slow them down if they're using our service disproportionately. It's important to pay attention to both read and write path, as the tenants could obviously cause disruption on both paths. And when we're thinking about these limits, there are certain dimensions that can help us to guide our decision when setting the limits. So most naturally, you might want to limit the frequency of the request and respond with an appropriate error message and a code to tell the client to retry later. Or we can also pay attention to the size of the request and set a limit for the total size of the request, and make sure that we refuse to handle any kind of outliers from the beginning. Still, relying solely on frequency or row size of the request, it's not sophisticated and predictable enough, especially when in the Prometheus world we're dealing with series and samples. So here we can borrow some concepts from capacity planning and think about how much capacity we would want to provide to our tenants. And here, active series can offer a good proxy for the number of series our tenant is currently using. But figuring how many active series a tenant has is also not trivial. Although this information can be inferred from the internal metrics of the Prometheus TSDB, in the distributed system, this information needs to be extracted from multiple instances of TSDB due to the nature of how things are handled, so there could be replication going on. And so we need to look at all of these TSDBs and calculate the active series based on metrics from all of these instances. One experimental approach we're trying at Thanos is to use what we call meta-monitoring approach, where we try to limit the number of series based on active series metrics from our whole Thanos deployment. And in a similar way, we should consider not only the active series, but we also should be looking at the potentially the number of labels and samples that your clients are sending you. Now, metering, similarly kind of to rate limiting, we'll also want to know how much of our service our tenants are using so that we can attribute our costs to them. And again, this is kind of a similar case to rate limiting. You might want to focus on the number of series and samples, again, our base units in the Prometheus world. And in this case, you should probably also not consider just the number of active series, but here also the long-term storage comes into play. So you should also consider the costs of long-term storage here.
Cool. So we've spoken about what MaaS is. We've spoken about how you would implement MaaS at quite a low level. And I guess what stands out to a lot of people is that it's a lot of stuff to have to worry about. It's a lot of stuff that you have to maintain. There's an option, which is you could pay someone to take care of it for you. So you could go find a third-party vendor, like Grafana, like AWS, like Google, and they could take care of the problem for you. They're generally pretty easy to adopt. It's usually a line of config that you add to your Prometheus setup. And oftentimes these services include some form of SLAs, platform support, etc., which is nice if you don't want to hire engineers to have to do that. Oftentimes these services are paid by usage. Matej kind of touched on this metering problem and kind of tracking and limiting users. It's pretty hard with Prometheus. There are a lot of different things that a user can do when they interact with your system. So oftentimes they're kind of similar. A lot of them track active series that you write, but some will charge you by samples, some will charge you for querying, some won't. Some will charge you for storage, persistent storage in the cloud. So it kind of varies. But with excessive use, as you're paying as you go, this can get very expensive. Moving metrics can also be difficult. Oftentimes when we adopt new and exciting technology, we don't really think about what it'd be like to unadopt it and use something else. So a lot of these services make it intentionally or unintentionally difficult to exfiltrate your data. So if you've been sending years of metrics to a particular place, and now you want to take those blocks or take that data out, it's sometimes tricky, or it can be expensive. There's also compliance. Not all of us work in industries where we can just publicly send telemetry and metrics out into the wild. Some of these vendors do offer on-premises solutions. So if you want to go with a commercial product, I recommend you talk to them. There are loads of representatives from those companies here today as well. And the second option is you could do it yourself. You could use open source software off the shelf, like Thanos, like Cortex, like Grafana Mimir, like Victoria Metrics. There are loads of Prometheus high availability persistent setups that you could adopt and deploy. But it is a challenge. It's not going to be easy. You're going to have to build context on these projects. You're going to have to run your own infrastructure. It's quite complex to configure some of these things because they're big distributed systems. And then you also have to pay for the compute. You have to pay for your Kubernetes cluster, your nodes. You have to pay for egress. You have to pay engineers to manage it. This is a non-trivial problem or non-trivial cost to doing this. But economies of scale, if you're consuming a lot of metrics, it might be worth it. You also have flexibility in your platform. You know where your data lives. You can change from Cortex to Thanos or Thanos to Mimir, however you would like. So you own your data, you own your infrastructure, you know where it is, you can run it in your own data centers if you're on-prem, etc. So this is kind of a matrix of some of the features we've spoken about today. Read limits, multi-tenancy support, monitoring, auth-C, authentication. I won't go through all the details, but you can see that various projects are in different levels of maturity when it comes to features that you need to facilitate monitoring as a service. And that's where observability as a service comes, because we love our X as a service in this industry. Now, observability as a service is kind of one level up from monitoring as a service. It encompasses multiple signals, so it will encompass your tracing, logging, and potentially your metrics, and continuous profiling if you have something like that. And oftentimes these observability as a service open source projects are meta projects. They kind of glue everything together and they put it behind an opinionated, opaque single API. So when you're interacting with it, you don't actually know where your metrics are being persisted or how they're being persisted. You just care that they are being persisted. Also, you have the benefit of having universal tenants and authentication authorization across all of your signals, which could be a huge benefit if you're offering this to other teams within your company, for example. And they're extensible as well. You don't have to use a particular ingester. They're often opaque APIs. They're open source projects, so you can contribute to them and change them. Some examples of these are Obstrace, which GitLab use quite extensively. I know they're here today. There's Observatorium, which is what we use at Red Hat. And OpenTelemetry, kind of. It kind of offers the same thing. But it doesn't really give you an opinion on authentication authorization. Cool. So what's this going to cost me? Is perhaps a good question. Like I said at the beginning, oftentimes observability is something everybody wants a lot of. Everybody wants high-resolution data, traces on everything that isn't sampled, logs for everything that are persisted for a long period of time. But all of these things have cost. So what I'm going to briefly do is a comparison between kind of three of the top vendors of monitoring as a service, Grafana, Google, and AWS, and a comparative setup with Observatorium and Thanos that could handle about the same amount of time series. For the sake of example, we want to persist 10 million active series, and we want to scrape or write these metrics twice a minute, so once every 30 seconds. So the setup that I ran this on was Thanos and Observatorium. We used about 300 gigabytes of memory, 15 CPU. That was about 5 EC2 nodes. We used about 400 gig of disk. You have to pay for some egress. And then that's the topology if you want to look at it, how many replicas of everything I'm running. This doesn't account for, what I'm about to show you in the next slide, does not account for the Kubernetes master nodes as well. So your control plane, depending on how you've adopted your Kubernetes, you either pay for your control plane or not. You have to factor that usage in as well. You also have to factor in the fact that you'll have an engineer that's going to be maintaining this for people. So this is vaguely the comparison. So we have some amount of active series, some scrape interval, and that gives you your effective data points per minute. That's useful for some vendors, not useful for others. For the sake of example, I've used the public calculators for all of these services. And another example that I wanted to draw attention to was that negotiated rate that Grafana has. Obviously, knowing that there's Grafana here, we went and spoke to them. We were like, hey, if we were doing this use case, how much would it cost us? What would it look like? And oftentimes, if you're sending a high volume of metrics, they'll give you better rates. So definitely talk to them before you adopt anything. And then at the end, you can see what it would cost in compute cost. Obviously, this is an oversimplification of this problem. There are a lot of other costs that go into running it yourself. But again, for me, it's useful data to just understand what the cost benefit is, and more importantly, how this scales with usage. So the more usage you have, the decision of whether you should run it yourself or whether you should pay someone to run it might change as well. And I wanted to give a shout out to this Thanos blog as well, Thanos at Medallia, where they managed to run a hybrid Thanos deployment that scaled to support a billion series across 40 data centers. The thing I kind of want to point at is I saw a lot of you use Prometheus, but not a lot of you use monitoring as a service. There is a trend in cloud native generally of people moving to multiple clusters, to regional clusters, to more complex topologies that might necessitate this. And we're seeing this reflected in Thanos with the features that people are working on and the importance of projects like Mimir and Victoria Metrics. Thank you, everyone. That's it.
Okay. Any questions? Anyone? No questions? Okay. Thank you very much.